Hi, it's time for another math easy solution. Today we're going to discuss further into the laboratory project, the one titled Bezier's Curves, and go over part 3 of it. And to quickly recap on the previous parts, and put the links in the description below, so make sure to watch those. Basically, the Bezier curves are these, well, the cubic Bezier curve is these set of parametric equations, x and y, and where t, the parameter t is between 0 and 1, and you have something that looks like this giant equation set where x and y are pretty much the same thing, but you replace x and y. From that, in part 1, we graphed it for a specific values of 4 control points, and I'll recap on those as well in a bit. And then part 2, from the graph in problem 1, I showed that the tangent line at the first control point passes through the second control point, and likewise for point 3, tangent line to point 2. And then now question 3 states, try to produce a Bezier curve with a loop by changing the second control point in problem 1. The second one is P1. So let's just quickly show you the solutions to question 1 and 2. So this is how a Bezier curve looks like. Here is in red the control points. We have P0, P1, P2, and P3. And the corresponding coordinates are x0, y0, etc., and x1, y1, and going all the way to x3, y3. And then at the first point P0, we have, that's when parameter t is equal to 0, and then at P3 is when the parameter is equal to 1. And then from question 2, I showed that at t equals to 0, or at this point, the derivative dy over dx is equal to y minus y0 over x1 minus x0. In other words, the slope here is the same, and it passes through this point P1. And likewise for this part here, at t equals to 1, dy over dx equals to y3 minus y2 divided by x3 minus x0, and that's this point over there. Basically from tangent line across here crosses over to point 2. So let's look at question 3. And question 3 states, again, we want to go over a loop. And so we want to create a loop by changing the second control point in problem 1. So we want to change this control point and see what happens to this curve right here. So we can move this left, right, etc., up and down, and see what happens. Just move it around. And what I've done is, well, I've created a, here's that same calculator from question 1. Let's just go open it in a Desmos one to show you what happens. So here is that curve, here's our giant equation. This is the x coordinate, and there's a comma, and then there's the y coordinate, and here's the values for each of these specific ones. So let's deal with, first, what I'm going to do is I'm going to hide this table. This one is drawing the control points and line segments of them. So now let's look at changing the y1. I'm going to move this up and there. Yeah, and so we have x1 and y1 here. I'm going to change this value up to, let's go with 100, and this one here, let's go to 0, and this x1, let's go to 120, and this one 0, and let's just see what we could do. And you could press play and you could change these and see what happens to them. So as you can see, we're changing the values, and yeah, we get a loop there. So let's just pause it once we get a loop. So notice how everything changes. Pretty amazing stuff. Let's just stop it there. Whoops, let's just keep moving this one here. So the loop looks like, if you look at x2 as 50, if we pass it, so before we have this, and if we pass 50, there looks like there's a loop there whenever this x1 is greater than this 50 mark. Let's just move this further. Yeah, as you can see, and then it goes back down all the way up to, again, below this x2 50, and then there's not the loop. And then above, yeah, actually like a bit more than above it. So 50, it's still not a loop, actually, yeah, so it's like just crossing it appears to have a loop. And what I've done is I've taken one specific value, that's for x1, this is P1, x1 equals to 110, and then y1 equals to 30. This is what I've done here, and I've screenshotted that. This is x1, y1, and we get a loop here. And then if you were to graph, put these in the table so you can get the control points, let's just do that here. So this one, let's go 110. It's the specific one. Whoops, 1, delete 0, 10, and this one was at 30. So we have 30 like that, and then show this, and let's just change these to 110, and this one to 30. This is a pretty cool calculator. You could change everything. Yeah, and we get a curve that looks something. It's something like this. Actually, I think there's a mistake here. Yeah, this point. Let me just see what the mistake is. No, actually, no, there's no mistake. This is correct. That's the same coordinates, and this is how the curve looks like. Let's see how our curve looks like. Yeah, it's the exact same thing. So yeah, there was no mistake. I thought I made a mistake, but so as you can see here, when you draw these control points, this one is our P2. This one's our P1. So when we move the P1, like pretty much the further across, we get a loop. I'm not sure the exact value, but notice here was the initial one was. Let me scroll back up. So P1 is initially here, and when we move this past the P2, and let's just go, and so basically it was somewhere around here, and then we shift it all the way across past the P2, and this is our P0, this is our P3, and then we get a kind of a loop like that, which is pretty cool. And there's our loop like that without the control points. And also, as from problem 2 or question 2, notice the tangent line here, it is exactly connects through the point 1, and same for here. The tangent line to this point goes all the way here. So if you draw this like here, tangent line across this goes there, tangent line across this goes all the way to there, which is pretty cool. Yeah, so it appears that moving the control point to the right of P2 creates a loop, but I think you might need to move it a bit further than just the right of it, maybe yeah, just a couple coordinate points further down it. And this also shows that why they are called control points, because they control how they control the shape, not how. Let's go so they control the shape of the curve. So basically, when you move these control points, you get this curve that gets changed, which is pretty cool. That's why they're called control points again. Anyways, that's all for today. This is a quick video on just playing around with that Desmos calculator, which is quite an amazing calculator. Just play around with it. It's amazing. And also to show you how you're moving the control points, you could change the curve, and in this case we got a loop, and also, yeah, let's just go to that loop again, and you could change it, and you could do pretty much crazy stuff with it, and crazy shapes, and then what you could do is also connect different Bezier curves together, so you could also piece together or connect, and you could draw pretty amazing stuff. And this kind of Bezier curves are actually used in computer-aided design, as well as when you go print something on your computer or type something in even in Microsoft Word. A lot of these characters or shapes or curves are using parametric curves like Bezier curves to develop these kind of curves, which is quite amazing, especially when you're printing stuff out. And also other computer-aided design stuff. Yeah. Anyways, that's all for today. Hopefully you learned. Like always, you can download these exact notes in the link below. Thanks for watching, and stay tuned for another Math Easy solution.